So this question, so it says if the hearing aid draws a continuous current, so the current is given to you. Understand all of these details. Current is given to you, I 0.095 milliamperes. Then they have given to you the time 12 weeks. Time 12 weeks. So 12 weeks is 7.26 times 10 to the power 6 seconds, right? Now from here you can find Q, charge. So Q is equal to
I is equal
Q is equal to IT. I is rate of change of charge. I is rate of change of charge. So method people, you will get this question as application in this way. So I is equal to Q divided by T here, right? So you get this one as dt of Q. Rate of change of charge is current. Huh? Now, okay, from here you can find Q, right? So I would be 0.095 times 10 to the power minus 3 amperes multiplied with time, SI unit is seconds, that's fine. So 7.26 times 10 to the power 6 seconds. So when you simplify this, what do you get? Can you quickly give me the answer?
691.
How much? Can't hear you.
689.
6? 8?
689.7.
689? Okay, fine. Coulombs, right? Charge is measured by what? Coulomb. Right? Coulomb. Right? Charge is measured by Coulomb. Now, this much of coulombs are there, so that means this much of charges are emitting from here. Do you get my point? The beauty. One electron has how many coulombs? One electron has how many coulombs? Huh?
6.2 times 10 to the power 18. Negative
6 point.
18. 6.2, wait, give me a second. Still here. Negative 1.6. Negative 19 coulombs. Negative 1.6 times 10 to the power negative 19 coulombs. One electron has negative coulomb.
Yeah, how did it be?
It's what it says.
Because it's a negative charge.
It just says that.
Because it's a negative charge.
You guys are saying it's really good. It's 1.6 times negative.
Negative, because it's potential energy.
Yes. So, okay, look at this. Look at this, guys. If you have A here, gives you A plus with 1 electron, and you are using 1 mole here, okay? You are using 1 mole here. If you use 1 mole, how many charges are ejected here? 1 farad is ejected. 1 farad is ejected. 1 mole, physics, calm down. 1 mole helps to eject 1 farad. Faraday is a scientist. Now 1 farad is equal to 96,500 coulombs. 96,500 coulombs, right? Okay, coming back to here. This is the rush,
Oh, you did work that time.
right? Then you have one here. This is one more, right? Stoichiometry, you know that. How many farads you are ejecting here? How many farads you are ejecting? 2 farads you are ejecting if you are using this much, right? Yeah? 2 farads means how much? 2 farads means how much? 2 times 96,500. Yeah? So, from here, now look at this. Actually, how many, so this is coulombs, right? See. So, actually, how many coulombs ejected from here? This much. You get my point? This much is actually ejected. So, how many moles you are expecting here? So, can you see 1 to 2 to 1 to 2 relation here? Right? So, if you get 2 here, you should get 1 here, right? Right? So, how many moles you are getting here? That's what I'm asking. Okay, look at this. From there, 1 is corresponding to 96,500 coulombs. Yeah. So you are having 690,89 coulombs. Do the reverse calculation. This is going to be 1 divided by 96,500. You guys are math people. Understand this clearly. This much of moles, right? This much of moles. Now you can see 1 is 96,500. That makes sense because 2 is this much. You are multiplying by 2, right? So 1 is that, right? So this much is this. However, you understand 2 to 1 ratio here, right? So if 2, so I'm saying this is 689 coulombs and that is corresponding to this much of moles, right? So I would say this is going to be my alpha, okay. So if this is alpha moles, if you have alpha number of moles here, how many moles you get here? Alpha divided by 2 moles, huh? Make sense? So how many zinc moles you are going to get here then? So here you get 1 divided by 2 times 1 divided by 96,500 times 689 number of moles you get. This much of moles you get.
3.6 times.
Right? How much?
3.6 times 10 to the power of negative 3.
3 point?
3.6 times 10 to the power of negative 3.
Negative 3 number of moles, right? Yeah? So you need to know how much mass is ejected, right? How much mass is used, right? So we understand that 1 mole of zinc is corresponding to how much is the molar mass? 65.4 grams per moles. Yeah, so 1 mole, right? So how many moles are there now? 3.6 times 10 to the power 3, right? So how much grams? 65.4 times 3.6 times 10 to the power minus 3. How much is the answer?
0.235.
0.23.
Okay.
That's quite simple.
That's the answer. Let's do this question. So now you can see, if you look at this question like as a whole, chemistry is there, physics is there, math is there, on top of that your intellect is there. You have to visualize this, then only you can do these things, nah? Yeah.
So where did the 96,500 coulombs come from?
Sorry.
The 96,500 coulombs?
So that's for 1 mole, so this is a constant.
Okay.
that has been already calculated. So 1 mole, if 1 mole is ejecting 1 mole of electrons actually. 1 mole of electrons. You can do that calculation. We'll try to do that calculation. What is electron mass? Sorry, electron charge. Electron charge. What is electron charge, guys? 1 point something? 1.602 negative 19 coulombs. This is 1 electron, right?
Yeah.
1 mole means what? 1 mole means how many electrons? 1 mole of electron means? What is Avogadro? 6.02 10 to the power 23. So 1 mole of electrons now, right? So 1 mole of electron charge. How much is that? That would be 6.02 10 to the power 23 multiplied with 1.602 times 10 to the power minus 19. Yeah? So what is this value? This is going to be 96, almost 500. 96, 500, what would be the unit here? Coulomb per mole. Coulombs per mole. Yeah? So, and that coulombs per mole is called 1 F farad. So 1 farad is that. That's what we are using. So that means, so this is indeed right. So if it is corresponding to 1 mole, we use 1 farad. Yeah. So this overall picture, intuitively, you have to have, you know, in a decent way. Yeah. Any questions? Why did I multiply by half? It's because of 2 to 1 correspondence. If you get this much, you get half of that. So I got the number of moles here, alpha number of moles. I divide that by 2 to get the number of zinc moles. So always this is important to logically argue. Yeah, SI units. SI units. So that's why milliamperes we convert it into amperes. You can see here. Milliamperes you convert it into amperes. See, because ampere is a SI unit. Second is SI unit. So Q is equal, I think, is what we have used, right?